when we graph this function, or frankly any function with a square root in it, really the first thing you're going to want to do is probably figure out what the domain is. That means figure out what x values simply won't work if you plug them in. And the fastest way to do that is to say, well, all the stuff inside a square root has to end up being 0 or more, because you can't have a negative inside a square root if you're going to work with real numbers. So I'm going to say right off the bat, the 2x minus 3 inside the square root has to be 0 or bigger, 0 or greater. And then if you solve this for x, you get x has to be 1.5 or more. So if you're going to make an xy table here, 1.5 would be a pretty smart number to plug in. That's going to give you the vertex of the graph. If we plug in 1.5, we're going to get this 2 times 1.5 is 3. Take away 3. That's 0 in the square root. The square root of 0 is 0. And negative 0 is still just a 0. Then we can plug in some other x values to the right of that. So let's plug in 2. That's going to give us 2 times 2 is 4. 4 take away 3 is 1. Square root of 1 is 1, and then make it negative. If we plug in 3, we get 2 times 3 is 6. 6 minus 3 is 3. On a calculator, the square root of 3 show up as about 1.7. So this is about negative 1.7. If you plug in 4, you get 2 times 4 is 8. Minus 3 is 5. So you get negative square root 5, which is about negative 2.2 if you round it off. And we'll plug in 5 here as well. 2 times 5 is 10. 10 take away 3 is 7. So we really have negative square root 7, which if you round that off is about negative 2.6, my calculator's telling me. So if you plot what you got here, 1.50 is about there. 2 negative 1 would be down here. 3 negative 1.7s, there's 3. And then 1.7 would be somewhere in there. 4 negative 2.2 would be about there. And 5 negative 2.6 would be somewhere in here. So our graph is going to go forever to the right, because x can always get bigger. But it's got to stop at the point 1.50.